In this problem, we're looking at adult male pulse rates, and we're told that adult male pulse rates are normally distributed with a mean value of 69.58 beats per minute and a standard deviation of 11.33 beats per minute. So I typically tell my students that anytime that you know that you have data that's normally distributed, go ahead and write down the mean value using the correct notation mu, and then write down the standard deviation value with the correct notation sigma, and make a sketch of a bell-shaped curve. Okay? All right, then next, go ahead and label the mean value by putting it at the center of your distribution because the mean value is always at the center. And then now this gives you a picture to try to help you answer questions dealing with probabilities. Question A says, find the pulse rate that separates the lowest 2.5%, and then also find the pulse rate that separates the highest 2.5%. So right now, we don't know what these pulse rates are, but I'll call the pulse rate that separates the bottom 2.5%, let's call that x sub 1. So I'll put a question mark here because we don't know what it is, but we'll be able to find it. And then the pulse rate that separates the top 2.5%, I'm going to call that x sub 2. So again, we don't know what that pulse rate is, but we're going to find it. So having this sketch of the bell-shaped curve at the bottom really helps us visualize the problem. So I'm going to mark x sub 1 on the left, and I'm going to mark a spot that's symmetrical to that on the right tail, and I'm going to call that x sub 2. So these are pulse rates that separate the bottom 2.5%. So I'm going to go ahead and shade in an area that represents 2.5%, and then I'm going to write that area down, but I'm going to convert that 2.5% to its decimal equivalency, and then I'm going to shade in an area with the same area on the right tail that also represents 2.5%. Okay? All right, so in this video, I'm going to show you how to solve this problem by using z-scores. So the formula for calculating a z-score is x minus mu over sigma. And then in the next video, I'll show you how to solve this same problem using your graphing calculator. So the first thing that we need to do is we need to first find out what z-score, so I'll start with the left-hand side here, what z-score corresponds to an area of 0.025 on the left. And because x sub 1 is to the left of the mean value, this means that its z-score is going to be negative. So that's why on the right-hand side here, I have a screenshot of the negative z-scores. And you can find a copy of this table. This is table A2 in the weekly lessons. Okay? All right, so what we're going to do is we're going to go to the body of this table, because in the body of the table is where we're going to find areas that correspond to a certain z-score. Okay, and these areas are always the area that's to the left of that specific z-score. So here I'm searching for 0.025, and you can find it right here. I just circled it towards the bottom. That corresponds to a z-score of negative 1.96. So that means that the z-score for x sub 1, its z-score is negative 1.96. I'll just mark that in blue here up at the top of the distribution. So z sub 1 is negative 1.96. Now, you can use the positive side of the z-table to find the z-score for x sub 2, but again, because this is symmetrical, it has the same area on the tail, I know that this z-score is going to be positive 1.96 because it has an area that is the same as the left tail there. Okay, but you can double check that on the z-table if you would like. So for x sub 2, its z-score is positive 1.96. So now what we're going to do is we're going to take this formula for calculating a z-score. This is called the conversion formula. And we're going to just solve it for x. Okay, so if I solve it for x, I'm going to write it on the right-hand side here. X is equal to z times sigma plus mu. So this is a formula that you should just start to memorize, because this is the formula that you want to use when you know the z-score and you're trying to work backwards and find the actual variable x. Okay, so to find x sub 1, I'm just going to substitute in the z-score, negative 1.96 times the standard deviation of 11.33, and then add the mean value of 69.58. So you can put that into your calculator, and it gives us a pulse rate of 47.37 beats per minute. So that is the pulse rate that separates the bottom 2.5% of pulse rates. And then now let's do the same calculation for x sub 2, but we're going to use the positive z-score, 1.96, and then multiply it times the standard deviation, add the mean value. So when you do that calculation, it gives us a pulse rate of 91.79 beats per minute. So that is the pulse rate that separates the top 2.5%. So watch the next video to learn how to do this on the graphing calculator.